Good afternoon. I want to present you the result of research on the antibacterial properties of material. As a rule, various coatings are deposited on the surface of implants. This is necessary to give them high mechanical characteristics, anti-corrosive properties, and biocompatibility. However, this coating don't protect the material from uh, interaction with bacteria, which leads to inflammatory process. As can you see, the bacteria are very evil. Therefore, in order to combat bacterial infection, it is also important to give antibacterial properties to material and maintain bioactivity. To solve this problem, the author of the article described to use the implantation of zinc and silver, as indicated in the figure. This was their main goal, but it's important to remember that the implants must hold tight after implantation. Otherwise, what's the point in them? Therefore, note that the second goal of the author was to preserve the compatibility of the implants. It was important to avoid toxic effect on bone cell. It showed to tightly envelop the implant, as can you see in the figure. In the world, balance is important for everyone, and the author also wants to maintain a balance of antibacterial and biological properties of the implant, which is very difficult. For this, it was described to introduce zinc and silver. This metal were introduced into material by ion implantation. This method allows you to enter elements at shallow depths. Modes of implantation of these elements are indicated in the table. Note that they are similar to each other. The material was examined by scanning electron microscopy, as can you see in the figure C and D. The outer received particle of silver on the surface of the coating. However, pay attention to figure B. There are not bright points on it. Since zinc particles don't form. It's estimated that silver and zinc form microgalvanic parts among themselves. Antibacterial tests were concluded against two types of bacteria. The slide shows the result of this text. As can you see, zinc has a small antibacterial effect. Silver kills even more bacteria. But the most powerful result is attached on the coating with silver and zinc together. Therefore, we can assume that the first goal of the author is fulfilled. Antibacterial coatings are created. Let's see what happened with biological properties. The structure of bone tissue cell was studied using fluorescent microscopy. Look at the picture, the figure. The cell will filled well on our surface. They actively explain it had a good cytoskeleton. All this suggests that the coating are biocompatibility. Such the author fulfilled the second goal of their work. In conclusion, coatings showed excellent antibacterial activity against two kinds of bacteria. Coatings contributed to growth and spread of bone cell. The antibacterial ability can be explained by synergetic effect of long-rate interaction extracted by zinc and the short-range argentum interaction arising from microgalvanic pairs in the implanted zinc argentum titanium. It's microgalvanic pairs. This work is very important, as its result will allow to fight inflammation during implantation. This will help people to stay healthy and save a lot lives. Thank you for attention.